Hello friends, myself Dr. Kilol Pandya from VT Patel Department of Electronics and Communication Engineering, Charotar University of Science and Technology, Changa, Gujarat, India. Today I am going to teach you the course EC242 Network Theory. We are going to start with lecture number 1, which is the introduction chapter. These are the topics that I am going to cover in lecture 1. Basics of network and circuit, difference between network analysis and network synthesis, types of network which is based on graph theory, dot convention method followed by its examples, waveform transformation examples followed by the exercise. So, first of all, we need to understand the two important words, which is network and circuit. So, what do you mean by network and what do you mean by circuit? An electrical network is the interconnection of electrical elements such as resistors, inductors, capacitors, transmission lines, voltage sources, current sources, and switches. So, network is just the interconnection of electrical components. Say this figure. Here I have taken three components: resistor, inductor, and capacitor, and I have connected three components through a copper wire. So it's called a network. It does not necessary that every time network should contain a closed path like this figure. Here there is no closed path, so it's called a network. Let's talk about the circuit. An electrical circuit is a network that has closed loop for giving return path for the current. So here in circuit, it's a condition that it must contain a closed loop for giving return path for the current. Look at this circuit figure. Here I have taken all three components, which is R, L and C. I have connected all three components with the voltage source and I have made a closed loop. So this is called a circuit. So in circuit, it is the requirement of forming a closed loop. So students, points to be noted down from these two fundamental definitions. Number 1, in circuit, the current has passed through all the elements, and in network, it is not necessary for current to pass through all elements. Second, the circuit is a special term and a network is general term. Third, the circuit have a completely closed path condition, but the network do not have a condition of closed path. Fourth, the electrical circuit is helpful in transporting the electrical power to make electrical lighting and to charge the storage batteries and also run the electric motors. Fifth, every circuit can be called as network, but every network cannot be called as circuit. So these are the important points that you need to remember. Now let us see the basic difference between network analysis and network synthesis. Network analysis: if the circuit is known and all parameters are given, the output in terms of voltage, current, power, etc. could be obtained by applying certain laws of network theory. The above procedure is called network analysis. So in simple way, we can understand that if the network is given to you, all the parameters have been provided to you, and you will be asked to find out the certain voltage, current or power. In that particular sense, you need to apply the network fundamentals and you are finding out the output. So this whole procedure is called as network analysis. So in short, we can say that the excitation is given and you will be asked to find out the response. That is called network analysis. Now let's talk about network synthesis. To get certain response from the circuit, carefully electronic components are chosen with appropriate values and the circuit is designed, which is called the network synthesis. So, it means here you should have in your mind that which kind of response you need to achieve. So, according to that response and according to that particular goal, you need to design a circuit, you need to take the appropriate values of the parameter and you are going to design the network. That is called network synthesis. So, in simple language, we can say that the response is given to you and you need to design a network to have that kind of response. It's called network synthesis. Now, let's go for the types of network. Here, the network could be categorized into 5 primarily types. First one is linear network, non-linear network. Second, active network, passive network. Third, unilateral network, bilateral network. Fourth, time variant network, time invariant network. Fifth, lump network, distributed network. Let us understand one by one. First is linear network and non-linear network. A network is said to be linear whose VI characteristics follows only one equation of straight line passing through origin for all time. Here, the word passing through origin for all time is very important. Let's go for this kind of examples. Here in all the examples, you may have the XY axis, they are nothing but our VI characteristics. Now, here in all 6 figures, I have drawn different slope of a straight line. Okay, so let us talk one by one. First of all, figure A. Here, the straight line origins from the coordinates 0, 0 and it is a straight line in first quadrant, but it is not having the equation of a straight line for all time because it is origin from 0, 0. So, it is discontinue before that 0, 0. So, that's why it is called non-linear. In case of B, it must follow the rules of passing through origin for all time. Here it follows the rule, so that's why it is said to be a linear. In figure C, it does not follow the rule of passing through origin and it is having the one equation of a straight line for all time. It does not follow the rule, so it's a non-linear. Case of D, it's a linear. Case of E, it is not following the equation, one equation of a straight line, so that's why it is non-linear. And of course, in figure F, it is not having the straight line of equation only one, so that's why it is of course non-linear. So these are the way by which you can find out the network or element is linear or non-linear. Now, second type would be active network and passive network. An element which delivers net amount of power to the circuit is called active element, and the element which cannot deliver net amount of power to the circuit is called passive element. The network which contains at least one active element is called active network. And if any of the network does not contain any of the active element is called passive network. Examples of active elements: voltage source, current source, battery. Examples of passive elements: resistors, inductors, capacitors, but with the condition if resistor greater than or is equal to 0, capacitor value greater than or equal to 0, also the inductor value must be greater than or equal to 0. Here there are two key findings by which we can decide that whether the network or element is passive or active. Number one is, if the slope of Vi characteristics is positive, it is called a passive element. If the slope of Vi characteristics is negative, it is active element. Let's understand. Here in figure A, you can say that the slope is positive. That's why the element is passive. In figure B, the slope is negative, so the element is active. Again in figure C, the slope is positive, so the element is passive. In figure D, slope is negative, so it is the slope of an active element. So, how we can easily decide the slope is positive or negative? So, this is the conclusion from this analysis, that if graph lies in first or third quadrant, every time the slope is positive, so it's a passive element. And if the graph lies in second or fourth quadrant, it's called active element. So students, mind well, if graph lies between second or fourth quadrant for a while, then also it's called an active element. So by this you can categorize the network is active or passive. Now the third type would be unilateral and bilateral. The element in which current can flow from both the directions is called a bilateral element. For example, if you go for resistor, you could go for inductor or capacitor, current can flow from either of directions. It means current can flow in any of the direction. So that's why these are the examples of bilateral elements. The element in which current can flow from only one direction is called unilateral element. So here current flowing is possible in only one direction. If you take the examples of diode and transistor, in diode the current can flow only from the positive side to the negative side. So when the diode is in feedback condition, the current can possible, so it is only in one direction. In the transistor itself also the current can flow in one direction, so that's why both are under the category of unilateral element. Now let's understand the unilateral network and unilateral and bilateral network. Bilateral network which offers same impedance when direction or polarity of voltage or current get reversed, otherwise it is called unilateral network. Let's understand the figure 1. Here the Vi characteristics graph is given, and here the equation of a straight line is given. Here in first quadrant there are two coordinates of V and I. One is V1 and second one is I1. So here the impedance Z1 would be V1 by I1. Same way, if you go for the two negative coordinates which are minus V1 and minus I1. So here the impedance is minus V1 by minus I1. So it comes basically V1 by I1, which is exactly as impedance 1. So if both the impedance are same, even though if we have reversed the polarity of voltage or current, it is said to be a bilateral network. So figure A is bilateral network. Let's go for figure B. Here also the Z1 and Z2 both the impedance having the same value, which is 1 ohm. So it considered as bilateral network. Every linear element is bilateral, but every bilateral element is not always linear element. So this is the thing that, dear students, you need to remember. Now let us understand the example of unilateral network. Here in the first quadrant there are two coordinates. The voltage coordinate is 8 volt, the current coordinate is 4 ampere. So Z1 would be 8 by 4, which is 2 ohm. Similarly, voltage and current has two different values, which is minus 6 volt and minus 4 ampere respectively. So here the impedance value would be minus 6 by minus 4 is equal to 3 by 2 ohm. So here if you compare, Z1 is not equal to Z2. So here the network is said as unilateral network. The fourth type of the network, which is time variant and time invariant network. It is basically very simple to understand it. The network whose VI characteristics changes with time is called time variant network. So here in the figure you can say that there are three equations of straight lines are given, and here all the lines are changing its V and I coordinates with respect to time. It means the behavior of the circuit changes with time. So that's why this kind of network is called as time variant network. The last type of the network, which is lump network and distributed network. A network in which resistors, capacitors and inductors can be separated physically is called lump network. Here I have shown you the three figures where the physical resistors, inductors and capacitors are shown. So simple, if you connect this in a circuit, so at any moment of time, if you feel, you can remove the resistor or inductor or capacitor physically. So this kind of network is called a lump network. But a network in which resistors, capacitors and inductors cannot be separated physically is called distributed network. They are distributed along the length of the network. So those parameters are distributed. Example is transmission line model. So here you cannot remove the resistor, inductor or capacitor because they are distributed over a line. So another difference is in lump network, whenever you are going to apply the excitation, it immediately applies to all the networks. But in distributed network, whenever you are going to apply the excitation, it transfer to that particular network phase by phase. So that's why it is called distributed network. So dear students, these are the 5 primarily types of network, or you can say that the elements. Now let's go for an exercise where you need to find the nature of the network. So here I have given you the 5 graphs. From the graphs you need to categorize the network in 4 types, whether it is linear nonlinear, whether it is bilateral unilateral, it is time variant invariant, and it is active or passive. Okay, so here you need to apply the fundamentals, that is what we have covered, and you can easily get the answers. Okay, so I hope you have done the exercise, and now I am showing you the answers so you can verify your answers. So by this way you can find out any kind of network type from the graph theory. The next topic of Don convention method, its example and waveform transformation examples would be continue in my next presentation. Thank you so much.